This is Unit 7, Day 4, Part 2. Okay, so now we have x minus 10 being divided into 2x squared minus 23x plus 17. All right, so now you're going to say, how can I change an x squared to a 2x squared? Or how many times does it go into it? Okay, so when we do that, you're going to say x times a 2x would be a 2x squared. So 2x times x is 2x squared. And then you're going to take 2x and multiply it by negative 10, and that's negative 20x. Put it in parentheses, subtract, but because it's that subtraction, you have to change all the signs. So this becomes negative and positive. Okay, so 2x squared minus 2x squared is 0. We always want that. And now you have negative 23x plus 20x is going to be a negative 3x. Okay, you're going to drop down the plus 17. And now you say, how many times can x go into negative 3x? Or how can you change an x to a negative 3x? By minus 3. So now, negative 3 times x would be negative 3x. And negative 3 times negative 10 would be positive 30. Put it in parentheses, subtract. But that subtraction now means you're going to change all the signs here. So that ends up being like a negative 30. All right, so negative 3x plus 3x cancel. But then you have 17 minus 30 would be negative 13. Okay, your Q of x, or your A, is your quotient, your answer. So 2x minus 3. This time it's minus because my remainder is negative 13, and it's out of the x minus 10 that we first divided everything by. Okay? All right, example 22. All right. So now this has a different way. It says sometimes we can use the structure of an expression instead of a polynomial long division. All right, so this way is a little bit harder in my opinion, but what it does is rather than using long division, it's saying watch how we can rewrite the numerator as an equivalent expression involving the denominator. So if you guys kind of look right here, it's saying, okay, so the numerator is x plus 8, the denominator is x plus 3. So the denominator stays x plus 3, so you want to rewrite that numerator using x plus 3, and then the equivalent has to figure that out to get up to x plus 8. So you're going to say, all right, well, if the denominator is x plus 3, I want x plus 3. If I use at least x plus 3 up top, x plus 3, how do I get that to go to x plus 8? Well, I add 5. Then this considers itself a 1. So now you have this whole little form here. All right, so it's a little hard to explain, but this is called quotient remainder form as well, okay? So you're just kind of rewriting it. And it's just another method instead of doing the long division, okay? So you're going to say, all right, so ready? Start with the actual fraction that they give you. So this is what I do. I write out x minus 2 on the bottom. I know I want x minus 2 on the top, but the numerator has to be x plus 6. Right now it's x minus 2. So you're saying negative 2. How do I change a negative 2 to a positive 6? Well, I add 8. Because think about this, guys. If I combine like terms up here, a negative 2 plus 8 would be a positive 6. So the only thing I did was rewrite x plus 6 as x minus 2 plus 8. That really is x plus 6. But look, here's the bottom. And this is what I was hoping for. I was hoping for that x plus 2. Now that I have that rewrite, it's really x minus 2 over x minus 2. That was this part in the blue box. And then I have an 8 over an x minus 2. So what does that mean? This whole thing really changed to a 1, but then I have plus 8 over x minus 2. Okay, so that is the whole quotient remainder form that it asked me to go into. It says, as a last resort, you can still use polynomial long division to answer the above question as well as the other ones that follow. All right. It says we can extend what we did in the last problem to more challenging structured problems. Write each of the following in a plus b over x minus r by rewriting the numerator as an equivalent expression. All right. These are a little harder, okay? These are a little harder. All right, so ready? I want the bottom x plus 2. So now I automatically put an x plus 2 up top, okay, because I want that match. But don't forget, you have a 4 out there, so it's like I factored out a 4. Now, if I want this to be x plus 2, don't forget, if you were to distribute this, it's really 4x plus 8. I need 4x plus 13. That means I'm missing 5. Okay? So it becomes 4 over x plus 2 over your x plus 2. So there's my numerator. Plus this leftover 5 with an x plus 2. Okay? What does that mean? It's really 4 times 1 plus 5 over x plus 2. Last step, you clean this up. 4 times 5, or 4 times 1 is really 4, plus 5 over x plus 2. So there's my answer in A plus B over x minus r form. Okay? Some kids say that this is totally 10 times more confusing, but you get used to it. So ready? Let's try it one more time. Okay? So the bottom is x minus 4. So I know I need the top to have an x minus 4. But look, this number up front is a 3, so I put a 3. So now in my head, I say 3 times x is 3x, but 3 times a negative 4 is negative 12, but I don't need negative 12, I need negative 5. So how does a negative 12 change to a negative 5? I have to add 7, okay? Because negative 12 plus 7 is negative 5. So now I have 3 times x minus 4 all over x minus 4 plus 7 over x minus 4. That becomes 3 times 1 plus 7 over x minus 4. 3 times 1 is 3, but I still have a remainder of 7 out of my divisor, which is x minus 4. Okay?